In this problem, we want to determine the differential equation relating this voltage V out to the input voltage V in. Now, if I have an energy storage element in the circuit, the first thing I'll probably do is, if it's a capacitor, label the voltages across it and the current through it. So for the capacitor in this circuit, I think I'll arbitrarily choose its voltage to be V sub C with this polarity. If I choose that polarity, then the current through the capacitor is going to be positive in that direction. It's C, which is 0.5 times dVc by dt. Now the capacitor is taken care of and I can worry about the op-amp. Applying the op-amp rules, I know that this voltage is 0 volts if I choose this as my reference. So if this voltage is 0 volts, this voltage is also 0 volts. Next thing I typically do with an op-amp is do KCL at the input terminals. So if I define that as node A and do KCL at A, so KCL at A says that this current, which is 0 volts minus V in over 2 ohms, plus the current through the 4 ohm resistor, which if I notice this resistor is in parallel with this capacitor, is V sub C over 4 ohms. And the current through the capacitor is just 0.5 dVc by dt, since it's drawn on my diagram. That's one equation with one unknown, V sub C, but it's not the unknown I want. I want to get this in terms of V out. So V sub C is this 0 volts minus V out. According to its definition, it's the voltage here minus the voltage here. So V sub C is equal to 0 volts minus V out, which is just negative V out. And I can substitute that in here and here. So making that substitution and taking this term over to this side, I get V in over 2 ohms is equal to the negative of V out over 4 ohms minus 0.5 dV out by dt, which is our differential equation relating V out and V in. Now, I'm typically going to want to check this differential equation before I start trying to solve it. The easiest way to check it is to let V in be a constant and see what happens as t goes to infinity. In that particular case, this is going to be a constant value. As t goes to infinity, the homogeneous solution will die out and we'll only have the particular solution left. The particular solution is going to have the same form as the input, so it's going to be a constant. If V out is a constant, this goes to 0 and we have V in over 2 is equal to minus V out over 4, so V out is equal to negative 2 V in. This we can check directly against the circuit. So the circuit, as t goes to infinity, with constant V in, becomes this voltage source, which is now a constant value, a 2 ohm resistor, the op-amp, this 4 ohm resistor, and this is V out. Under these circumstances, the capacitor is an open circuit, so we have a purely resistive network. Now if we do KCL at A here, we get 0 minus V in over 2 plus 0 minus V out over 4 is equal to 0, and V out is equal to negative 2 V in. That matches with this, and we're pretty comfortable with our differential equation.